Okay, let's get started. Today we're going to cover section 14.1. This talks about 4 different voting methods that we'll be learning to use. In the next section we'll learn that there are certain flaws in voting methods, and we'll discuss that in section 14.2. But that will not be today's lecture. This lecture is in lieu of March 6th, 2014. Probably the best thing to do in this situation is begin by talking about a preference table. A preference table lists an individual's preferences in a voting situation. Here I've made up an example, and I've enlarged it so that hopefully it will be easier for you to see, and we'll be using this to learn about the methods by actually just kind of working through it. First of all, let's read the situation. This table is a preference table. Dr. Rizzo's class is studying young adult fiction this semester. After reading Harry Potter 4, the students were asked to vote, ranking from highest to lowest. Vote for their favorite of the 4 champions participating in the Triwizard Tournament. Harry Potter, that's A, Victor Crumb, B, Fleur Delacour, C, and Cedric Diggory, D. The election results are as follows. So what this table is telling us is that these 14 people ranked the candidates in this order. Their first choice, all 14, put A. Their second choice was B, third choice C, and fourth choice D. However, these 10 individuals, these 10 people, voted for C as their first choice candidate. Look over here to see the place. As their second choice candidate, these 10 voted for B. Their third choice was D and A. They are the only 10 that ranked them in exactly that order from first to fourth. 8 in this order and so forth. So from this table we can get a lot of different types of information. The first method of voting that we're going to discuss is called the plurality method or plurality voting. And I will tell you what that means. Plurality voting. This method says that the candidate or candidates, if there is more than one, with the most first place votes wins. So plurality voting counts the most first place votes. That's the way we typically vote. I ask for a raise of hands in class. Who wants this? You raise your hands. Whoever doesn't want this, raise your hands. Whichever has the majority, the most first place votes, that would be the winner of the situation. And that's because we're only looking at one thing. We're only looking at a person's first choice rather than the ordering or the preferences overall. Notice that the only information used from the ballot is the votes for first place. Nothing else matters. What would be wrong with a plurality method? Now let's go ahead and work this example. Find the winner with each of the methods. That's what we're going to do. And the first method we're going to do is plurality. Okay, so we need to count the first place votes. So what I'm going to do is I'm going to list the candidates. We have Harry Potter, A, Victor Crumb, B, Fleur Delacour, C, and Cedric Diggory, D. Now I'm going to look at the table. I'm going to slide this down over what I've written, and I'm going to look only at the first place votes. First place. Candidate A receives 14. Candidate C receives 10. First place, candidate D receives 8. First place, candidate B receives 4. And finally, C receives 1 more, giving a total of 11. So the winner using this plurality method is Harry Potter with most first place votes. But let's look. How many people voted in this particular situation? Let's count the number of voters. All right, slide this up a little. The number of voters. Well, go across the top and read the number in each group. We have 14 plus 10 plus 8 plus 4 plus 1. Okay, let's add that up. Grab your calculator. Giving us a total of 37 voters. Okay. So it's kind of interesting if I ask the question, did Harry, that's A, right, win a majority of the votes? A majority being over half the votes. Well, he actually won 14 out of 37 votes. He received 13, and there were a total of 37. So let's take that on the calculator. 14 divided by 37 gives him 0.378, so forth, who cares, right? And as a percent, this is 37.8% of the votes. So you can see he really wasn't that popular. He received more of the first place votes than anyone else, but he certainly didn't have a majority of the votes. In fact, if you look at the table closely, it looks like he's pretty unpopular. In fact, they either love him or they hate him, right? So really, more people hate him, put him at the bottom, than those who actually put him at the top. So one flaw in this particular system plurality method is that it doesn't take into account other things, other rankings, other than first place. And we can see overall he really is disliked by the people who voted for their favorite Triwizard Tournament champion. Okay, that's the first method. Let's look at the second method of voting. That's plurality. It's not too hard. We'll do another example using all the methods in a minute. The second method is called plurality with elimination. And I'm not sure this is the order that they introduce these in the book. It doesn't really matter, of course. This method is like survival of the fittest. This method of voting keeps eliminating the most unfit candidate, one by one, until there's a winner. So they take the biggest loser, so to speak, the one who has the least votes, and eliminate them. Fitness means, in this case, the number of first place votes received. What's wrong with a plurality with elimination method? Okay, let's look at this method and determine the votes here. Now, as we did in part 1, we calculated the first place votes. And we came up with 14 for A, 4 for B, 10 plus 1 giving us a total of 11 for C, and D received 8 votes. So if we look at this, the most unfit person who receives the fewest first place votes would clearly be B. So we're going to eliminate B as the most unfit candidate at this point. So I'm looking for a pencil because I'd like to be able to erase this in a minute. We go through the table at this point and we eliminate B very lightly because we'll be reusing this table again. I'm eliminating B. So if someone voted for B for first place, with this preference table I can now take into account their second choice, and I'm not completely throwing away their voice in the election, which is an advantage of this method. So now we're going to, once again, this is like round 2, we're going to calculate, let's just call this round 2. Which means we should probably go back and rename this one round 1. Okay, on round 2 we're going to do first place. And this time we only have candidate A, C, and D. Okay, we go to the preference table. 14 people put A in first place. 10 people put C. 8 people put D. 4 people put B, who we eliminated, so we go to their second choice. This is now their first choice of the remaining candidates, so those 4 votes will now go to D. And this person chose C as the first choice. And so we have 11 there, and we have 12 here. So we eliminate the most unfit. And so we're going to eliminate C. And this seems fair because we're taking into account at least people's second preference if their person's not a winner, right? Okay, so I'm going back through my chart now, and I'm going to eliminate C in each column because they are no longer in this. And we're ready for round 3. We just keep doing this until we're down to 1 candidate. Eliminate the biggest losers here, right? Okay, now we only have A and D remaining in this comparison. 14 for A, 10 for C, eliminated. 10 for B, eliminated. Their first choice now of the people who are left would go 10 votes to D. 8 people voted for D. 4 people voted for B, who is eliminated. Their second choice is D. And this one goes to, as you can see, their first choice of who remains. And so that's definitely more than Harry, but let's add it up. We'll get 23 votes for candidate D. So we can now eliminate the biggest loser, right? Eliminate the lowest first place votes. And so at this point, we can declare the winner D, which was Victor, right? I think so. Yes, Cedric Diggory. Sorry, Cedric Diggory. Now, this is interesting because by doing a different method, we have found a different winner, okay, with the same exact data. And in some ways, you can see how each method has an element of fairness and also a flaw, okay? And it doesn't seem quite fair, really, that the person who got the most first place votes didn't win. And in this method, that did not happen, okay? All right, we're ready for the third method. Voting method number 3. Where did that go? There we go. The third method is called pairwise comparison. And it kind of tells you what we're going to do. We're going to compare pairs, right? This method works like a round-robin tournament in which every candidate is matched one-on-one with every other candidate. Each of these one-on-one matchups is called a pairwise comparison. In a pairwise comparison between candidate X and Y, each vote is assigned to either X or Y, the vote going to whichever of the 2 candidates is higher on the ballot. The winner of the pairwise comparison is the one with the most votes. A win is worth 1 point, and a loss is worth nothing. In the case of a tie, each candidate gets a half a point. I think there's one on your My Math Lab homework that there's a tie. Just remember to give a half a point. Or if they tell you to do otherwise, do whatever they say. Okay? All right, we bring the table back up, and we erase the eliminations because we are doing a different method, and everyone must be allowed to compete. Okay, method number 3. This is pairwise comparison. Okay, now first of all, we need to list the pairs. We have to compare, and you want to leave a blank line between each of these to write down your math, okay? We want to compare A versus B, Harry versus Fleur, and see which of those, of the pair of them, is more liked. And then we're going to compare A, Harry, versus Cedric. And then we're going to compare Harry versus, I'm sorry, that should have been, C should have been Fleur de la Cour, and that's Cedric. Anyway, it doesn't matter. We have to do A and B, A and C, A and D. Now, what about B? Let's start with B. Did B compare to A? Yes. How about B and C? We need that one. B versus C. We also need B versus D. And we've already done B and A, so we don't need that. Then we have C. We've already done A and C and A and B and C, so we need to do C versus D. And that actually concludes all the pairs. Okay, now we need to figure out which of each pair is more liked, okay? So let's look at the table comparing A and B and see which is liked more in each of the group of voters that are in this problem. Okay, first we're comparing A and B. In this column, these 14 like A higher, they have that first place, and B is lower, it's second place. So these 14 votes will go to the winner of that pair comparison. These 10 put B higher than they did A, so those 10 votes will go here. This column, 8, they put B above A, so they prefer, of the pair, they prefer B more. These 4 prefer B, and this one prefers B more than A. Well, you can tell that B has a larger total. I think we added this up before, but we will do it again. Get your calculator out. 23 votes went to B, and that's more than 14. So over here we want to put a little tally for the number of wins. Oops, W-I-N-S. I was watching the computer instead of what I was writing. A, B, C, D. B has 1 win. We give them 1 point. That's what they said. If you win a pair compare, you get 1 point. If it's a tie, you get a half point. Okay, now we're comparing A and C. Okay, in this column, they like A more than C. 14 votes over here. In this column, they prefer C. And in this column, they prefer C over A. 8 more. See, A's at the bottom, so I already know what's going to happen. 4 there and 1 there. So again, 23 people like C more than A that they put at the bottom, and only these 14 put A on top. So we can see that C wins this round. Okay, that pair. C is a winner of that. Now let's compare A and D. All right. A and D. A is liked more than D by these 14. And then here we go again. A is at the bottom, so that means D has to be higher on all the others. So 10 plus 8 plus 4 plus 1. Again, 23 people really don't like Harry very well. So D wins this pair. We give a vote, a win to, number of wins, we give a win to D. Now we compare B and C. This might be a little more interesting, I hope. Okay. In the first column, B is higher than C, so 14 go to B. In this column, C is higher, so the 10 votes go here. These 8 votes, they like C more. These 4 votes like B more. And this one likes C better than B. Okay, so that's going to give us 19 over here and 18 over here. So C's the flat-out winner of that. We give 1 more win to C. I tend to put plus instead of changing the numbers. Okay, now we compare B and D. In the first column, they like B better than D. These 10 like B better than D. It looks like they're going to win already, but let's finish it up. These 8 like D better. These 4 like B. And this one likes D better than B. Well, I can tell they're a winner. You don't even have to add it up if you can tell. Add it up if it makes you feel better. I don't feel compelled to do that tonight. And we add that as another win for a whoops. That should have been a win for B, shouldn't it? Okay, we put the 1 up there. Okay. Now we do C and D. Okay, going down the first column. Do they like C better? Yes. 14. These like C better. These like D. They like D more. And these like C more. Again, C is liked more than D in this one. We get 25, and that's just 12, right? So C is the winner here, so I add another one to C. And so at this point, I can call this one the winner. The winner is C, because they have the most number of wins. Interestingly enough, Harry didn't win a single pairwise comparison. When you compared him one-on-one with each candidate, he was not preferred. So in some ways it would be unfair for him to be picked the winner. Of course, we know he's the hero, so he should be. But in this voting situation, the mathematical point is that in this individual comparison, which seems like a reasonable way to look at people, C keeps coming out ahead more than any other candidate and is chosen as the winner. C has not been chosen before. We have yet a third winner using the third technique. That was Fleur Delacour, I guess. Okay, method 4. The fourth method is, I keep losing that one page. Here we go. The fourth method is the Borda count. This is really kind of fun, but you have to be careful because it's easy to make a little arithmetic mistake. Each place on the ballot is assigned points. In an election with N candidates, we give 1 point for the last place, 2 points for the next to last place, and so forth, up to N points, with N being the highest. The points are tallied for each candidate separately, and the candidate with the highest total is the winner. So this is kind of like an overall likability quotient. It will make more sense when we do it. So let's go ahead and work this with our example. First we take the voting scheme, and they said the last place is going to be given 1 point. And next to last place, 2 points. And then 3 points. And we keep going ever how many places till you get to the top, increasing each time by 1. So those are the points that will be assigned by the place. And we're supposed to do each candidate separately. And this is how this is a little bit different. Well, several ways, I guess. But we're going to look first at A. I think it's helpful to go across the top and take the headers and put the number of voters in each column. So we have 14 voters in the first column. That's a 14. 10 voters in the next column. I'm leaving this to put the points in. 8 voters. 4 voters, and 1 voter. So these are the number of voters. And now we have to look at where they rank them and how many points they'll be giving them based on this Borda count method. So we're looking at candidate A. These 14 put A in first place, and first place awards 4 points. So I have to give 4 points right here for these 14 putting it first. These 10 voters put A at the bottom, which gives only 1 point. So they're giving 1 point, and everybody else put it at the bottom. So every other time it's going to be given 1 point. So that makes this one kind of easy. And then we simply, and I will work this out showing the steps the first time, and then after this you'll just have to do it. 14 times 4 is 56, plus 10, plus 8, plus 4, plus 1. I'm multiplying order of operation, and then I'm adding. And we should get a likability total, or a Borda count total, of 79 for candidate A. Okay? Let's separate the paper there. We'll come back and compare these in a minute. Now we're going to do the total for B. And we go back And again, I always start out by putting those column totals that will help me get my overall total. Alright, then I go back through and I look at candidate B and kind of trace them through the thing. These 14 put B right here, which if you move over here, it's for 3 points. So I put a 3 for those 14. These 10 put B right there, also for 3 points. These 8 put B there for 2 points. These 4 put B at the top place for 4 points. And this one put B in third choice for 2 points. I find it helpful to just slide my finger over and make sure I get to the points and I don't read the place, because if you put the places down here, you'll get the wrong total, obviously. Okay, well, I said I wasn't going to go on and do this, but I guess I will. We have 14 times 3, 42 plus 30, plus 16 plus 16 plus 2. So I multiplied it, now I'm going to add these up. And I get a grand total of 106 for candidate B. We can already see that this is a higher total, so at this point B would be the winner over A. But we have 2 more candidates that we have to get the board count on. Candidate C now. Again, begin with the totals. And again, I found this to be helpful in not getting things scrambled up. Okay, those are the heading totals, and now we go through and look at candidate C and account for their place. These 14 put C in that place and it gets 2 points. These 10 put C right there for 4 points, just slide over. These 8 put C here for 3 points. These 4 put C down there for 2 points. And this one put C there for 4 points. Okay. And here we go again. 14 times 2 is 28, plus 40, plus 24, plus 8, plus 4. I multiplied, and now I'm going to add 28 plus 40, plus 24, plus 8, plus 4, giving this candidate C 104 as the likability total, right? Okay, and so at this point, B is more popular with this particular scheme. That's Victor Crumb, and I don't believe he's won yet. This first example I kind of rigged for you. Candidate D, same thing. 14, the number of voters at the top of each column. You will probably want to put an example like this one on your note card to keep the method straight. Okay. Candidate D. These 14 put D at the bottom for 1 point. D is right there for 2 points. These 8 put D at the top for 4. These 4 put D right there for 3. And this one put D there for 3. Okay. Now we multiply and add. We have 14 plus 20 plus 32 plus 12 plus 3. Okay, I multiplied those. Use your calculator if you're prone to making mistakes. And I'm getting 81 as my total for D. Okay. Now if we look at these candidates with the board count and their totals, 79, 106, 104, and 81, we see that the winner is now candidate B using the board count. So we had the winner as D, A, B, and C using each method. What's the advantage of this method? It kind of takes into account how you feel overall. It's a weighted thing. It's the kind of an overall likability total is kind of how I think of it. Okay. All right, we have done one example using all of the 4 methods, and we need to do another example. The second example on the lecture notes is not like anything you're going to see, so we'll just X that out and we'll work on the third example, which is very much like something that might appear on a test or on my math lab. Okay. The preference table on number 2 that we're not going to do is presented differently. not in a way that you're going to see. Okay. In this particular situation, their candidates, I think it should say 3. 3 candidates are running for president of the Student Government Association. Alice, A, Brian, B, and Kathy, C. That makes it easy. The results of the election are shown in the following preference table. Okay, there they are. These 13 people picked A first, B, C, and so forth. Okay? Seems that I like to change this before we get started, the number of people in that last column. Let's change this last column to a 2. Okay? Alright. How many students voted in the election? Now I've changed it a little, and that would certainly not be something I would expect you to do. I will give you a change if there is one. Part A, how many students voted in the election? We simply have to go across the top to get the total, and it's 13 plus 11 plus 9 plus 2, giving us a grand total of 35. Okay, so a total of 35 in the election. The second question on the lecture notes says, how many students voted for Kathy as the first place? Okay, for Kathy, we're going across and looking for the first place. First choice was Kathy with these 11 people. And first place was Kathy with the last 2. Okay. Now let's go to part C. And these are just questions that test whether you are able to read the information accurately and understand the way it's presented on the table. Part C, who would win the presidency using the plurality method? So we're going to pick the winner using plurality. So we need to go through and look at the first place votes for A, B, and C. All right. Let's see if I can fold this a little more strategically here. Okay, first place votes. 13 put A, 11 put C, 9 put B, and 2 put C. So that gives 13 to C and 13 to A. So we have a tie with A and C. Now, on the test, if there is a tie, I will give you instructions about how to break the tie. I will usually say, take the one who has the most second place votes, or use a different method if there's a tie. So don't worry about that. And my math lab should tell you also how to break a tie. But for today, we're just going to say there is a tie. Okay. Part D. Who would win the presidency with the Borda count? Alright, so they're doing these in a different order this time. That won't bother us. With the Borda count, that was kind of the likability total. We get the total number of points for A, and then B, and then C. We begin that by going to the preference table and assigning 1 point for last place, 2 points for next to last, and so forth up the preference chart. Okay? Now if you remember, we go across first and we take the number at the top on the headers and we fill in those and leave a blank to put the points. Okay, so now that I've done that, I'm going to go through and I'm going to look at the place for A in each of these columns. These 13 put A at the top, which assigns 3 points. These 11 put A in that place for 2 points. These 9 put A there for 2 points. Again, just slide your finger over is the best way. These put A at the bottom for 1 point. Now we multiply and add. We're going to have 39 plus 22 plus 18 plus 2. Okay. 39 plus 22 plus 18 plus 2, giving us a total of 81 on the board doc count for a candidate A. Okay, I'll slide that up. I guess you couldn't see all of that a second ago. Who would win using the plurality with elimination method? Alright, remember that you can pause and rewind if that's needed. Part E, we're going to do plurality with elimination. Okay, so this means the first place votes with eliminating. So we do round 1, and we do the first place, and we're looking at A, B, and C. Now we did that a minute ago. Let's see if I can put my hands on it. First place votes came up with 13, 9, 11 plus 2, giving 13 here. And this is kind of an awkward one because we have a tie. We now would eliminate the loser at this stage. On round 1 is B, and then we have to go through round 2. Luckily, it wasn't the loser that was tied. That would be kind of confusing. I'll try not to let that happen. And again, we're going to look at the first place of the ones that were not eliminated, A and C. Okay, that means I need to go to my chart and take my pencil and eliminate B. Eliminate B, eliminate B, eliminate B, eliminate B. And I'm using the pencil so I can erase that and reuse the chart in a few minutes. Okay, we're looking for first place votes. 13 put A in first place. 11 put C. These 9 picked B. We have eliminated, so we use their second choice. Their voice is not lost, and A gets those 9 votes. And these 2 votes go to C. So we have 13 here, and we have 22 here. And so at this point we eliminate the lowest. And when we look at them this way, eliminating the one with the fewest votes and taking into account their second choice, we get the winner as A, using the plurality with elimination method. Okay, that was part E. Let's look at part F now. Part F asks us, who would the president be using the pairwise comparison? Method. If a tie, use the plurality method between the winners to determine the tiebreaker. And usually on any situation with a tie, there will be, and in fact at the front of the test I will put directions if you have a tie what you should do, okay? So we have to think about the pairs. We have to compare A versus B. We have to compare A versus C, and again leave blank lines to do your calculations. And then we still have to compare B and C. Each person needs compared with everyone else once and only once. So here we go back to the chart. And I now need to erase the eliminated because they are no longer, we're not using that method now. Okay. Beginning to compare A and B. These 13 prefer A more than they do B. So the 13 votes go to A over B. These 11 like A more. These 9 prefer B more than A. And these 2 prefer B. So I have 11 there. And we have 24. We can see we need to count the number of wins. And the candidates that we have are A, B, and C. And A just won the first win. Okay, now we're going to do A versus C. A is chosen over C for the first 13. These 12 prefer C more than A. Sorry, it's 11. These 9 prefer A. And these 2 prefer C over A. 22 and 13. So we can see that A again wins. At this point, folks, we really don't have to do the last one. I'm going to, but if they want to know B or C, even if they, well, one of them will win it, they can't possibly get more points than that. So on a test, I would stop. But just to be thorough, I'm going to go ahead and compare B and C. Okay, these prefer B. These prefer C. These prefer B. And these prefer C. And clearly B gets more this way. And so one win goes to B. But we declare once again the winner. So sometimes you get the same winner doing different methods, and sometimes, like in the Harry Potter situation, you get a completely different winner with the different methods. That's all we need to do in this section. Please now complete the homework on MyMathLab. The homework for section 14.1. Let me warn you that it is way down at the bottom of the list of homework, and it's easy to overlook. But it does have this due date for the third test because it will be included on the third test, and you now need to do it before we come back after spring break. We will pick up with section 14.2 at that time, talking about voting flaws, and you'll need to have completed this and also completed 8.4 on annuities. Hope you have a good holiday, and I'll see you in a couple of weeks.